All right, so we're going to continue with 5.9. That's why it's 5.9b. And we just got two examples. Do the two examples. We'll be done. I'll let you work on this in class, this homework assignment in class. Well, the second one. You had a first assignment, didn't you? Right, and then you got a part B. So let's go through this first, and then we'll shut the YouTube down and go over the homeworks together in class. All right, so here it is. This is example 3. And we're solving for x. These are inequalities, remember? So it's x squared plus 2x minus 5. Yeah, I heard. Okay, is greater than or equal to 0. So now, we got a little bit of an issue. Yesterday, what was the first thing that we did with that? What was the first thing that we did with this yesterday? Yeah, we factored it, okay? When you have a trinomial like that, it's the first thing I would look for is to try to factor it. But you got a little issue with this, don't you? Can you factor that? No, because what times what is 5? 5 and 1, that's it, right? Either -5, +1, or +5, -1. Is there any way that I get a 5 and a 1 to add up to a 2? No, so I can't factor this. So what do you think my next best option would be? Would be the quadratic formula, absolutely. So what we're going to do is we're going to find on that number line where our x's are, okay? So I'm going to say equals, well, actually, this is greater than or equal to, so I'm okay with even saying equals. So what I'm going to do is just solve for x, all right? It's not going to be my complete answer, right? Because I got to put it on the number line, got to put my points there, then I got to try some numbers, right? Is it positive? Is it negative? That kind of stuff. So, but I got to find out where on my number line am I going to put those points. All right, so what do we do? Negative b, right? So -2 plus or minus square root b squared, so 2 squared, which is 4, minus 4 times a, which is 1, right? That's the a, times c. What's the c? It's -5. Make sure you take that sign in front of it. That's super important. Over 2 times a, or 2 times 1. I don't really need the 1 there. Really didn't need it here, did I? All right, let's finish this up. It's -2 plus or minus square root. What's that? 20 plus, so 24, right? Over 2. Let's simplify the square root of 24. What would you use? There's a couple things that multiply to be 24. Well, several things. I'm going to pick something in particular. 6 and 4. I always like to put the 4 first, all right, because that's the one I can take the square root of. You can put 6 times 4, it's fine. But I like to put that one first, okay? And that's over what? 2. Let's continue this. It's -2 plus or minus. What do we got? Square root of, this is 4 times 6. So it's the square root of 4, which is 2. And then the square root of 6, I can't do anything else with it, so I just keep it the square root of 6. And this is all over what? 2. With me? All right. No? Okay. So watch what we get. We get -2 over 2. Yes? Plus or minus. What? 2 square root of 6 over 2. Let's simplify. What's this? -1. Let's just do the plus right now. Is that all right? And what's going to happen here? That's going to go. So it's -1 what? Plus square root of 6. So that's one of my x's. What's my other x? -1 minus square root of 6. Now, I have no idea where that is on the number line, so guess what I'm going to do? Use a calculator. That's exactly right. So I'm going to put that into a calculator. So x, I'll put approximately to be kind of careful. The plus one was 1.45. And I don't have to be exact on these. I just have to know those regions. I'm just looking for the regions. And then when I subtract them, I get -3.45. Everybody good? Okay, so that wasn't that hard, just quadratic formula. Then stick it into the answers into a calculator. Now, this is the part where the inequalities come in. You wouldn't have to do this if it was just equals 0. All right, if it was equals 0, you could have just left it like this and this. All right, that would have been your answer. But these are inequalities. So this is a number line. So let's put the two numbers in. I got negative 3.45, so that's negative 3.45. And this is what? Positive 1.45. Everybody good? Yeah. So remember what we did yesterday? We got three regions. We got this one over here, in the middle, on the left. All right, so I want to pick a point somewhere in this region. Pick an easy point, nothing crazy. All right, you could pick a crazy number, I guess, but that would be silly. What would you do? To the right of 1.45? You could. Okay, but there's our situations, and I don't see it. I remember watching a YouTube guy do these, and he said something about, I forget what he said, but I'd never seen that before. It was like a little trick to know, like if this is positive, that would be negative, that would be positive, but that doesn't always happen. All right, there are situations, and I forget what he said to look for. It doesn't matter because I can just try all three anyway. Because when I was looking at it, I'm like, okay, that's nice, but I could still just plug a number in. It shouldn't be that big of a deal. So what am I plugging it into? I kind of I'm plugging it into this. X squared plus 2x, plus 2x minus 5 is greater than or equal to 0. Okay, that's what I'm going to plug it into. Everybody good? So what's a good number that you could use? A 2, right? Let's put a 2 in for this, okay? So put a 2. So 2 squared is 4, plus 2 times 2 is 4, minus 5. What's that? 8 minus 5. 8 minus 5 is 3. Is 3 greater than or equal to 0? Of course it is. So that means so this will give me a positive number, okay? Let's just do it like we did yesterday. All right, so that'll give me a positive value. All right, Zach, what are you going to pick now? Pick a 0. 0 is in between these two. All right, put a 0 in there. Okay, watch. 0 squared is 0 plus 0 minus 5. That minus 5 is what? It's negative, okay? Let's put a number less than 3.45. Now, don't put like negative 3.46, okay? Pick a super easy number that's just to the left of negative 3.45. Negative 4, good. All right, so let's put a negative 4 in for this x. Can we do that in our head? Yeah, I think we can. So watch. Negative 4 squared is 16. Plus 2 times negative 4, which is negative 8, correct? Minus 5, that's 8 minus 5 is 3. It's positive, so guess what? Everything over here is going to be positive. So what are we looking for? We're looking for all the stuff that's greater than or equal to 0, which means positive, right? Okay, or equal to 0. So what am I going to do right here? I'm going to put a circle, but what am I going to do with that circle? Open or closed? It's closed because it could be equal to it. All right, same thing right here. Closed circle right here, shaded in. So now I'm going to shade. I need all the positives, right? That's why I look right here, okay? I need all the positives, so that's going to give you positive values, and everything over here is going to give you positive values. So that's your graph. So why did you do all that stuff on the graph? Because sometimes they don't even ask you to graph it. I don't think on any of these they actually ask you to graph it, but it's very, very helpful to us. Okay, it helps visualize what's going on. So what do we do? How do I write my answer? I could write it a couple ways. Let's do it the way the book probably does it, with that inequality notation, right? So what would you say here? X is what? How would I write this? How would I write that? Is less than or equal to what? That negative 3.45. But let's write that as an exact answer. Remember what the exact answer was? Because this is an approximation, isn't it? Negative 1 minus square root of 6. It's probably the best way to write it, okay? And then you could say or x could be what? Greater than or equal to, what's this number, this 1.45? Negative 1 plus square root of 6. Good. So that is one way you could write your answer. What's another way that you could write your answer? I don't think the book will do this. I don't think if you flip back and it's an odd problem, I don't think you're going to see this notation, but I'm just giving you a heads up. All right, just trying, since we're here, I figure might as well show you here, because later on, you're going to see this notation. You're going to say, oh, okay, I get that. What's another way to write this? Remember, how far do we go to the left? To negative infinity. How far do we go to the right? Positive infinity. So what's this part right here? How do I write that part right there? It's a parentheses, right? Because negative infinity, you never get there. So it's negative infinity to where? We're not going to write the decimal. What are you going to write? Negative 1 minus square root of 6. I know it's weird. It's kind of awkward looking. All right, but that's what that number is. All right. Is it closed or open? It's closed. So what kind of symbol do we put here? A bracket. All right. And then what we put is a weird thing in between. What is that? A U for union. All right. And then what do we do here? So now we're starting here. So what kind of a end? It's a bracket. And what's that number? Negative 1 plus square root of 6. And that goes all the way to where? Infinity. Positive infinity. Good. So either one of these would be fine. This is probably what you're going to see in the book. All right. You might see this later on. All right. But really, if you want to write it either way, I don't care. Probably should say, do it like the way the book's going to do, because when you do, when I read off the answers or whatever, that's probably how I'll read it off. And if you look in the back of the book for the odds, that's probably how you're going to see it. But I think it's good to learn this way, because when you get into college, they probably won't be doing this kind of stuff, even the higher math, maybe later on in this book. Again, it's the first time I taught this book, so I'm not really sure if they do teach you that notation down here. But they eventually will at some point, somewhere along your math career. All right. Let's do one more. Yes. Yes, write a pass. Yeah, a parentheses is open. It just means open. So like if this didn't say greater than or equal to, if it just said greater than, then these would be circles, okay? And actually later on, they're going to graph. Here, I'll show you. Later on, they're going to graph it, not with arrows and shaded in. Well, actually, they may shade it in. But instead of open circles and closed circles, this is what they're going to do. All right, so if there's our point, there's our point. If this is closed, watch. Let's do this in red. Give me just a second. All right, so watch. This is what they do. All right, so you might see stuff. Now, they do shade it in, but instead of open circles and closed circles, they put brackets. Or if this was not or equal to, they would put a parentheses there. All right? Does that make sense? Again, just so that when you do see it, I won't have to go through all that explanation. I can look back on this and say, hey, remember back then when we did that, whatever they called that. What did I call that notation? I wrote it down yesterday. Not expanded. What do they call that? Anybody write that down in their notes yesterday? What did I call it? Interval. Is that what you said? Yeah, interval notation. Very good. Yeah, you got to remind me. I can't remember what I did 10 minutes ago. All right, so interval notation. All right, good enough. You ready to do another one? Let's do this one. Last one, example 4. It looks pretty much like what we did before, but the answer is going to look kind of weird. All right. So first of all, look at this. There's no 0 there. So what are you going to do? You're going to put this on the left-hand side, put a 0 there, right? So add a 3 to both sides. So x squared plus x plus 3 is less than 0. That's the first thing you do, okay? Put it in that quadratic notation, I guess. All right? So what was the first thing we did on that last one? We said, well, let's see if I can solve for x. Can I do it by factoring in this situation? No, because it's a 3. 3 times 1 is 3. Is there any way I can get a 1 out of a 3 and a 1? No. Whether it doesn't matter if they're both negative, both positive. It doesn't matter. There's no way I can get a 1 out of that. So what am I going to have to do to get x? Let's do the formula again. If you really wanted to complete the square, if you like that better, feel free to do it that way. Okay, it doesn't matter how you do it. But I think the formula is the best way to go. So let's do it quickly. -1 plus or minus square root b squared, which is 1, minus 4 times a, which is a 1, times c, which is a 3, over 2a, which is a 2. -1 plus or minus square root. What's happening here? 1 minus 12. It's a -11. What happens? It's an imaginary number, isn't it? So what we're doing, we're only finding real answers. So are there going to be any real answers? No, because this is an imaginary number, okay? So that automatically tells you right there, I can pretty much just stop if I wanted to and say, this is going to give me an imaginary number. It's not a real number, so there are no real solutions. I will not. Maybe. Don't know. Haven't made up the quiz yet. No, you won't. All right, so there's no real solutions. So that's, you stop, okay? There's no number line because on the imaginary number system, there's number lines, they kind of exist, but they don't as far as we're concerned. We won't get into that, but there's just no real solutions, okay? Yes? All of them? Is that what you said?
Oh, wait, no, I'm not asking you.
Oh, thought you said, can I solve all of them?
No, I'm not like, can you?
You want me to do one?
No, I'm saying that, okay.
Oh, do they all have solutions?
No,
Is that?
Like, can you solve all the problems, like how we would solve that equation instead of like, factoring?
Yeah, you could. Sure.
But I'm asking, does it matter?
But, yeah, this works every time. But factoring, a lot of times, if it's an easy factoring, right? If you have a coefficient of 1, it's almost always easier and quicker to factor it and get a solution for x than it is to use this. Could you use this every time? Absolutely. Okay? Is it the best way? Not all the time. Sometimes it is, right? Definitely here, okay, it was. Really, the only other way I could think of solving this is to do completing the square. And completing the square is fine, but I think it's a little bit more involved than what the formula is. Does that answer your question? Okay. Anything else before we let you do the homework? Well, now you should be able to because we went through all the examples. So now you can look at your old homework, right? See what you couldn't do. I'll read off the answers to you. Did I give you evens? Yeah, okay. So I'll read off the evens to you. You can see how you did on those, right? And then you can work on the second batch that I'm giving you today. So the first batch was 1 to 14, correct? So that was A. So that was what, 5-9? 5-9A. And then 5-9B is what we're working on in class today. And if you don't finish it in class today, you can finish it. It's to 14, not 4, sorry. This is 15 to 32. All right. So you got almost a half an hour. All right. A little less than a half an hour to work on these. And I'll tell you what, I'll collect them both tomorrow. All right. Collect them both tomorrow because I want you to look at these. I'll read off the answers as soon as I stop my recording here. I'll read off the even answers. Then you have a good idea if you knew how to do them or not. But you should have had a good idea just by looking at the odd answers, right? But I'll read them off anyway. Everybody good?